this section, we're going to look at complementary events. Now, we're going to be working from the same problem we had used before. We were looking at randomly selecting a person who uses a credit card frequently. So we've answered the first two questions in the previous section. Now we're going to look at the bottom two. What is the complement of P frequently uses credit card, and what is the probability of this complement? The complement of an event A consists of all the outcomes in which event A does not occur. This is denoted by P with what we call parentheses over score A within the parentheses, or P not A. So when we're looking at solving for the complement, we need to take a moment and look back at our figure of the probabilities. So remember, here's our diagram of probabilities from 0 impossible events all the way up to 1 certain event. This figure is the equivalent of the figure on the left. Notice in both of them, the total area is equal to 1. 1 is all possible probabilities, meaning something somewhere has happened. Okay? So this is basically the image we're going to be working with now on the left with the pink and the yellow is basically another way of representing the full probabilities of 1. So let's move forward with that. Here in this particular figure, P of A stands for P frequently used credit card. The pink area stands for P not A, which is the P not frequently using the credit card. Now notice, not frequently using the credit card does encompass never using the credit card or sometimes using the credit card. So it actually encompasses 2 of the 3 possible outcomes. However, if we're simply interested in reorganizing this information to be either A, frequently using a credit card, or not P of A, which is the not using a credit card frequently, we can simplify this problem a bit. So here we can see the total area of an event occurring consists of P of frequently using the credit card plus P of not frequently using the credit card. This gives us all possible rates of using a credit card, including never using a credit card. Applying the algebraic translation of this, we get the ultimate formula here of P of A equals 1 minus P of A. So P of not A equals 1 minus P of A, and we can use this formula then to quickly calculate the complement event of P of A. Now, this can be really important if you're looking at a situation where perhaps you've got 5 or 6 different possible outcomes, and you don't want to go through and calculate the probability for each of those separate outcomes and then add them together. So let's take a look at this. Here we can see what is the complement of P of A. Well, that is P of frequently used credit card. Well, it's going to be P of not A, so P of not frequently using the credit card. And here we can see the formula. We plug these numbers in. So when we find what is the probability of this complement, that is going to be 1 minus 0.670, since that's the probability of A, which gives us the complement of 0.33. Now, just to check this real quickly, we can go through and see if we calculate these by hand. So we take the P probability of never using a credit card, which would be 169 divided by 4,230. We get a probability of 0.040. If we take the probability of sometimes using a credit card, we get 1,227 divided by 4,230, and we get a probability of 0.30. So notice that if we're adding together those two probabilities, we get 0.34, which is roughly the equivalent of the 0.33 that we had, considering that we've rounded the 2 upper numbers. So because we've rounded each of them as we've gone along, that has thrown off our calculation just a little bit. So we can see here that what we're calculating with the complement formula is the equivalent to if we had taken those separate probabilities and added them together, but is obviously a lot faster. So this concludes our section on complementary events and how to calculate them.